join us, the better. So let's see if my button here works. Might work. Yes, it does. Uh-oh. Now, what is this? Soft phone connection? Let's stop that. So here's the basic products that Midnite Solar offers. PV combiners. We probably make more PV combiners than anyone else in North America. They're presently fairly simple combiners, although the new ones we're actually shipping now are not so simple. Disconnected combiners. Pre-wired inverter systems. Most people know that we offer these systems using Magnum Energy and Outback Power inverters and very shortly SMAs. We haven't really pushed this, but all of the distributors and some of the dealers out there are using our pre-wired systems mainly because it just saves time. We're good at building them, and the nice thing is when it arrives at the customer's doorstep, it's crated, it gets there in good shape, it's been tested, it works, you just put it on the wall, hook up your batteries and generator and PV, and you're off and running. Battery boxes. Outback, excuse me. We're Midnite here, right? Okay, Midnite makes a lot of battery boxes. We have probably the only listed battery boxes. They're what I would call a fairly lightweight battery box, trying to keep the costs down. Most of them ship unassembled, all except for our C battery box. And we do have a couple of more in development right now. One of them in particular is going to accommodate 8D batteries. That's something that we're weak on. We do accommodate them now, but it's not very efficient use of space. So we're going to be able to accommodate 8 of the 8D battery boxes, and I believe this is going to be in an outdoor enclosure. Lightning arresters. This is something we've been doing for, what, maybe a year and a half now. The reason we do lightning arresters is because I was doing some testing one night here on deltas. And it turns out that deltas don't act the same way that I have always been told that they act. They were supposed to arc over at about 700 volts. And that was based on what an engineer told me at Trace Engineering back in the 90s. So I decided to test them one night here. And turns out, no, I was off by about a factor of 10. They don't protect anything until over 7,000 or 8,000 volts. Well, that's not really protecting anything, is it? So because of that, we decided to make our own lightning arrestor. MPPT charge controllers. Most of you are aware that, yes, Midnite does make a charge controller. That's something that we're very good at. Bob, my brother, who you'll meet here later on, developed the Outback MX60 charge controller, which arguably was the world's largest selling MPPT controller for many, many, many years. It might still be, although we're catching up quite fast, just because what we've done now is, well, it's 10 years newer technology, and we've learned a lot. E-panels. Pretty much everybody in the industry has used our e-panels. It's the least expensive and the most space-conscious way to hook up a battery-based inverter. One thing I always tell people is you got to have circuit breakers over current protection. You got to have tie points or bus bars. You need slider bypass assemblies. There's all sorts of things you need in a battery-based system. But all of these things that we put inside the e-panel do not make your system work any better. They are all necessary elements of a system, and what we provide is many hundreds of dollars less expensive than, let's say, what Magnum offers and what Outback offers. I always tell people, don't put your money in the circuit breaker boxes, put it in solar panels, or put it in the inverter, put it in the batteries, something that actually gives you better performance in your system, because the e-panels, the Magnum Energy version, and the FlexWare and stuff, they don't make your system work any better. It's just one of those necessary things you have to have. Breaker boxes, yeah, we do some mini DCs, baby boxes, quad boxes. We make some boxes that just aren't available anywhere else in the world. So we fill a bit of a void there. Battery capacity meter. I'll show you that in a bit. You may be familiar with it. We have a very simple voltage-based battery capacity meter. All the other ones out there, like the Trimetrics, the BMK from Magnum, the FNDC from Outback, these types of things, they're shunt-based. They're quite a bit more complicated, and they can give you more information than our battery meter can, but they always get off. Over time, they will definitely get off. There's no question about it. We hear from people all the time that they don't know how to use them. Well, ours is very simplistic because it's voltage-based. It does have a lot of smarts built into it, and it has some features that none of the other ones have, all for a $69 price tag. Circuit breakers. Something else we'll talk about briefly, just because we do a lot of circuit breakers. All the distributors pretty much buy from Midnite now, mainly because we don't charge a lot of money for our breakers. We stock tons and tons of breakers. We ship over 100,000 a year. And there's quite a price difference between us and the other suppliers out there. Why? Well, we just don't charge a lot of markup, that's all. So here's basically the products that we just went over. If you're not familiar with our products, we'll be going over all of these one at a time during this talk. By the way, I do appreciate you guys giving up your Friday afternoon when it's time to go home just to join us here. We'll try to schedule some webinars a little earlier on in the day next time. PV combiners. This is the front of a brochure that we have, and this is really only covering our new disconnecting combiners, which they are shipping now. Not everyone in our brochure, but they are shipping. Here's our standard combiners. If you don't know about these combiners yet, then you're obviously not in the solar industry. These two right here, the MMPV3 and MMPV6, are industry standards. It's just a simple little box, but it's a very, very well done box, and it's priced right. By the way, the price of those two do go up $10 January 1st. Unfortunately, we're having our first price increase ever January 1, and we'll try to keep it to as few products as possible and as low as possible. But the erosion, the price erosion has just been eating us alive during the last 7 years since we've never had a price increase. Most companies increase prices every year, every two. Here is a 4-string disconnecting combiner. You'll see two different versions here. We actually have 3 different versions. The one on the left is the most basic version. This is more like what we ship on our standard non-disco combiners today. It does not come with fuses, does not come with fuse holders, doesn't come with the strain reliefs, doesn't come with the SPD 600. But it does have the bus bars for 4 fuses. You can see them poking through here, the dead front. It does have the 100 amp switch, but this is only what we call a 2-pole switch. And how the switch is made, it was very custom made for us by Carling Technologies. There are 2 100 amp 300 volt switches in series. So you put them in series, you get 600 volts. It's still 100 amps. Once you go to our deluxe, and this is a deluxe unit over here that actually is pre-wired as well, we put a 3-pole switch in here. The 3rd pole is the shunt trip pole as well as the position sensor. You could shunt trip this one. It actually has 2 wires that could be done, but we would not know what position the handle is in back down on the birdhouse, and we'll get to that in a minute. You can see a circuit board up here. This is what we call the bird nest, but this is actually taking power from the solar array during the day and feeding power downstairs to our emergency disconnect switch. And we have not made it very clear on our website up until recently that if you do buy our birdhouse, which is the emergency disconnect switch, you also do need the power supply. You can see this wiring here. This is just something we offer. I don't think it's on our price list yet, but we do have a price. You're the first ones to see what the price is because we just came up with it last night. $689 list for the deluxe pre-wired. Pre-wires are sort of interesting. Dave Katz at AEE, we were talking about pre-wired a couple of years ago, and he just couldn't ever figure out why anybody would ever want a pre-wired, because the wires coming up to the combiner are always going to be the wrong length. Or you have to make them on site, and if you're going to do that, you may as well just cut the ends off and run them right into the fuse holder, and I totally agree with that. Here's why the pre-wires actually do offer value. Some of the bigger jobs, commercial jobs out there right now, in fact Ryan was just down at one in Massachusetts because we screwed up some of these pre-wires, frankly, and he went down to fix them. But what they do on these big commercial sites, and they bought 100 or 200 of these combiners, they can hire lesser skilled people to install the panels on the racking and hook up the wires. It's pretty hard to screw up the wires. You've got a PV plus and you've got a PV minus. And of course you've got the connectors on our combiner here. You just plug them in and it's done. There's another reason for the disconnecting or the pre-wired up in Canada. They have different rules up there, and unless you're a licensed electrician in Canada, you are not allowed to cut the wires and install them. So most of the solar installers that have grown up with the solar industry, they're not necessarily journeyman electricians or licensed, whatever they're called in Canada. And so they can actually hook up the hard part of the system, which is getting the whole PV array wired up to a combiner, if it's plug and play. So we do offer these for anybody who wants them, and I'm surprised. We actually sell quite a few pre-wired combiners. It's not like we've done a whole lot of educating to even exist. So anyway, so we have three different types. We have the basic at $429 retail. We have the deluxe, and what you get on the deluxe, of course, is the 600 volt SPD, and all combiners should have a lightning protection of some sort. Then you get the fuses, the fuse holders, and all the strain reliefs. All of our other disconnecting combiners only come basically as a deluxe model. There's no stripped down model. Okay, well I think we just covered all this. The PV4 Disco. Now here's the 6. This is an older picture. Our gaskets are actually much nicer than this now. We do NEMA 4X units as well now. Boy, did we get caught with our pants down designing a NEMA 4X box, and that was me personally. I did not realize that these NEMA 4X boxes, in order to pass the UL standard, had to be watertight 6 feet underwater for an hour. It took us a good 6 months to actually pass that test. Every possible place you could get water in a box, we got water in the box. So we would nail them one at a time. We learned a lot, and now we have some extremely well-built aluminum, welded aluminum construction boxes that are called NEMA 4X. What's interesting is, as I'm going around, walking around shows like SPI and Intersolar and things like that, I'll walk by the competitors and check out what they've got, and they always cost more than us. But I have yet to see a NEMA 4X box made by a competitor that would pass our test. And I think the reason is that every one of them, without fail, goes and they buy a standard off-the-shelf box. Those boxes don't have any holes in them. They have to be modified in order to turn them into a combiner, because they're just buying an empty off-the-shelf box. Once they start poking holes in them, that's where the fun begins. And of course, we actually ship all of our combiners with the holes for the strain reliefs and the output. They're already there. On the NEMA 4Xs, they're not knockouts either, they're actual holes. So we have to ship them with hole plugs as well. And yeah, we had to learn the hard way on hole plugs too. I actually have 10,000 hole plugs here that didn't work. So we give those away with the NEMA 3Rs just because they're always on the bottom. You know, if you need a hole plug, feel free to use them. They're great. Just don't put them on the top of a box. But the NEMA 4X, all of them, they come with, again, the fuses, fuse holders, the SPDs, strain reliefs, hole plugs. They all have clear dead fronts. This one just isn't showing the dead front. You'll notice here, this white, this is the terminal bus bar. We have snap-on covers. They just snap straight on. They come right off. This is nothing that's actually required, but I thought it would be a good idea to have a cover over these high voltage bus bars for when you do have the plastic dead front removed as well. And it's just a nice feature to have. Now here's the NEMA 4X and NEMA 3R 8-string combiner. Now we're getting into something that we call the convertible combiners, and no one else offers this. What we do here is we provide enough of these minus bus bars right here and the plus bus bars, as well as copper bus bars, these things here, tin-plated copper, to be able to configure this thing 3 different ways, because we don't know how you're going to want to hook it up. The first way you can hook it up, the way we ship it, is all 8 of these fuse holders in parallel. Now you look up here and you can see 2 bus bars running down to 2 different sections of the switch. This is actually a 2-pole switch. The middle pole here is the shunt trip and position sensor. These are each 300 volt, 100 amp switches, so these 2 are in series. Here's your input, there's your output. Second pole, here's your input and here's your output. So what we have going on here to parallel all 8 of these is these 4 come down here to this switch, and then the output is on this bus bar, which you can't see very well, on the bottom of the switch. And then is also paralleled with the output of the second switch here. And then the total output comes down here, so here's your main output. This is now a 175 amp switch when it is parallel. It's 100 amps per pole when they are used separate. A second way you can hook this up is for using 2 totally separate inverters. So you can have independent inverters here, 4 strings, and another inverter here. This is a quite common thing to do, but you have to have 2 PV minus separate terminal bus bars. So that's why you have 2 white bus bars here. We also give you a bus bar that connects these 2 up for when you have all 8 of these in parallel. So in this case, when you're using it for 2 totally separate combiners, you'd remove this bus bar, you would remove the parallel bus bar, and then we give you another one that goes from this first switch out here to your secondary output. Basically, you got a lot of copper pieces that when you're done with your installation, you're going to have a lot of copper and these high voltage bus bars left over. It can be useful. These are very useful 600 volt, 200 amp bus bars that come with the snap-on covers that are shown here. You're going to have enough copper pieces where you can go recycle it and go buy a pizza. It's a very heavy-duty pure copper bus bars. On the 8-string here, you can barely see these things that are adapters on the bottom. This is something we're going to do for a while. One thing that, oh, by the way, the third way to hook this up is for non-grounded inverters, transformerless inverters. And what you have to do there is these 4 guys can be used for PV minus. These 4 can be used for PV plus. You have to have a 2-pole switch because you have to disconnect both of them. So now here's your output for the plus, and for the minus we give you another bus bar that will run right over to here. And what you would want to do in this case is take this bus bar out, take this bus bar out, fill up the holes, and we give you the parts to make the watertight holes filled up. Throw those in your toolbox. Those are really nice, expensive bus bars. There's no reason just to leave them with the customer who's never going to use them. Okay, back to these adapters. We found out through one of our dealers that when you're using transformerless inverters, and they are all going to be transformerless as required by the 2014 code, they require the 1000-volt PV wire. Well, 1000-volt PV wire is a larger diameter than the 600-volt wire. And depending on what strain relief you've got, they will not fit through a strain relief that goes in a 1/2-inch knockout. So what we did, trying to be proactive here, is we make these adapters. We actually punch the holes out to a 3/4-inch knockout size. We make these adapters, and these adapters will accept the 1/2-inch strain release. Now we provide the strain release, we provide the adapters, and we provide the hole plugs. So no matter what you're doing, you've got the parts to do the job. Since we've designed these adapters, which are really nice, useful adapters, by the way, and you'll have some of those left over too, as well as hole plugs, we have found some strain reliefs that fit in a 1/2-inch knockout, and they do accept the 1,000-volt wire. It's tight, but they do fit. So long term, we may decide to get rid of the adapters and just put the 1/2-inch strain relief holes in, so it reduces costs. So here we have the prices on these. I believe these are all on our website too. Now we get to the MMPV16. Right now, this is our largest. This is NEMA 4X. They all come as the deluxe. They come with all, again, the fuse holders, the hole plugs, fuses, fuse holders, SPD 600s. This is, again, the 2-pole switch. And this one also is a convertible. So you can hook it up 3 different ways, and you've got all the parts that come with it to do whatever you need. It does only come with a single SPD, though. So if you're actually running 2 different inverters on it, you may decide you want to buy another SPD 600 to protect the second inverter. The reason we chose aluminum over fiberglass is a couple of reasons. I don't like fiberglass, for one. You talk to the installers down in Arizona, ask them how long those combiners are going to last as compared to aluminum. And they say, well, they're not going to. Aluminum 100 years from now is still going to be a watertight box. The fiberglass boxes made by virtually all of our competitors will have turned to dust. And then they're all available in steel as well. And I don't know why you would want to put a steel combiner up on a roof, because that's going to rust out. And you don't really want 600 volts DC in a rusted out steel box. At least I wouldn't want it out there. So take your choice. By the way, our aluminum boxes, they don't cost any more than our competitors do. I think pretty much they're less expensive. And you get all the features and all the strain release and all that garbage. And the lightning arrestor. No one gives away a lightning arrestor for free, but we do. Arc fault combiners. This is an example of what we're going to be shipping off to one of the major inverter manufacturers in a few weeks. We started developing the arc fault combiner a couple of years ago, and since then it became required by code that all the inverters have to have arc fault detectors. Well, all the residential sized, up to 6 or 8 kilowatts or so, are going to be coming with their own built-in arc fault detectors, just like our classic charge controller does now. But they will not work on your 50,000 watt or 500,000 watt inverter. That's going to have to be an outboard arc fault detector. We happen to be putting them into a combiner. The first one we do will be around 24 strings. This will be coming out this year. Certainly should be, since we are shipping out a fully functional unit in about 3 or 4 weeks. And it will retail for $2,400, which really isn't bad. I think some of our competitors' 24-string combiners cost $2,400 just without the arc fault detector. Another thing about ours is it is also a string monitor. So if you buy a 24-string combiner, you've got not only the string monitor and the arc fault detector, we also provide the monitoring site at no charge. Now you can still go and hire DEC or Fat Spaniel or some of these other guys that you have to pay fees to. And frankly, they will probably do a much better job of the software. They'll make it fancier. They've been at it longer than we have. What we provide is, however, at no charge. And of course, we will grow and get better at our software as well. But basically, you want to know what's each string doing. You know, you got voltage and you got current. There isn't a whole lot else to it. Another thing that we do offer on this that no one else offers is we will be able to shut down from a parallel arc fault. Now that was going to be a requirement in the 2014 NEC code. They have taken it out. Why? Because no one has figured out how to do it. We have. We're confident that we can detect a series or a parallel arc. And believe me, you have to do different things depending on what type of arc it is. It's difficult. This is very hard stuff to do. It's a lot of fun for the engineers because they get to beat their head against the wall. But it's difficult to do. Now up here on the top right, you'll see a power supply board. That's actually a whole lot more than just a power supply board. That actually has inputs for wind and solar radiance, temperature. It's got your Ethernet output. It's got RS-485 output. And that power supply is powered by the solar array. Pretty much all of our competitors that do string monitoring or remote shutoff, you are forced to run AC wiring up to the combiner. We didn't really want to have to force people to do that, and since we have a bunch of electronic engineers, we just built our own power supply board that runs off the PV array. If you want this thing to monitor your array in the middle of the night when the sun's not working, well, you can run AC up to this combiner, and there are terminals on here to run 24 or 36 volts right into the board, and it'll be powered up all night long. Otherwise, it just goes dead during the night, and it waits until it wakes up in the morning. But you can have it both ways. This power supply board up here, by the way, also powers our birdhouse. And you do not have to order a second power supply board with the birdhouse when you use the arc fault combiner. You do have to order a separate power supply when you're just using the disconnecting combiner, because it does not have a power supply as standard. Okay, somebody's writing a note here. Not really voltage. NEC 2011 requires arc fault protection, and on systems with more than 3 to 4 strings it is hard to detect. Absolutely. Makes sense to monitor it at the combiner. Yeah. You can use Tigos too if you got lots of money and shading. So the one thing that we have noticed here, that this must be Ryan that wrote this, is we've decided...
Yeah, I'm answering questions on the chat.
Great. Well, one thing that we noticed during the 2 years of development on this particular arc fault combiner is if you try to pick out an arc on more than about 4 strings, it gets very, very ifsy. Take, for instance, the Solar Boss. And they're really good guys, but they're trying to develop their own arc fault detector, but they're going with 8 strings. Well, there's a couple of other people out there that are doing what we're doing. Eaton, you know, it's no slouch. Those guys are pretty sharp. Their arc fault detector uses 4 strings. Then there's Samcon out of, I think it's Holland or the Netherlands. They have a module you can buy that just does arc fault. You have to add your own power supply and all that stuff. But it also does 4 strings. So there's a couple of other companies that have been heavily involved in the arc fault detection, and they came up with the same exact configuration that we did, using only 4 strings at a time. This might be one of the reasons why the Solar Boss 8-string arc fault detector, I don't think it's on the market yet. It's too many strings in our opinion, and it's not going to be reliable. So if you turn up the sensitivity so you can get 1 out of 8, you have a much higher chance of nuisance tripping. And if you lower the sensitivity, which I think is what they've done, the demonstrations I've seen from the Solar Boss, it takes 2 full seconds to detect and stop an arc. Well, when you got a 600-volt arc, 2 seconds, that's enough to start a fire. we're thinking that our arc fault detector, when it all settles down, will be less than a half a second. Very difficult stuff to do, but a lot of fun. And again, this will be coming this coming year. Here's another disco. This is a really simple disconnecting combiner. Tom Carpenter here works for us, technical sales in Hawaii. He's showing you how to hold a handle. But what this is actually doing when you move that handle is it moves circuit breaker handles up and down. This does not have that 100 or 200 amp switch inside. This is strictly our CBI QY breakers. It can also be the AC breakers. This box here very well might have AC and 600 volt DC breakers in the same box. It's listed for it. It's all legal. No one else has ever done this to my knowledge. That's a fairly inexpensive box. I think it retails for like $200. We also have a micro version for like N phases and those, where you can have up to 3 strings of 240 volt breakers, leg 1, leg 2 breakers, and you're turning them on and off by just moving the handle one direction or another. And we just offer different bus bars with the micro version. That is the only difference. Birdhouse. This is our emergency shut-off switch. It's very Art Deco looking. We copied a 1920s fire pole switch that we saw on eBay. As it turns out, you guys on the East Coast would know this design very well because they're all over the place on the East Coast. They're still being used. We have no idea when we designed it that these things were actually still used for fire alarms. In fact, I even saw one in San Francisco a few months ago. But this is kind of a cool little switch. It does a few different things for you. It is solar powered from the combiner, those power supplies that we talked about. What it does is it feeds you 50 volts coming down a very custom 600 volt Cat5 cable that we have made for us in Israel, of all places. It's 90 degree C rated, so you can actually run it right in your same conduit as your PV wiring, perfectly legal because it's all rated for the same temperature and voltage and all that. Well, what happens at nighttime when a firefighter comes up to this thing? They don't know that solar panels don't put out voltage at nighttime. So they pull the door down there and they push the button and they're expecting it to shut off the combiner up there. And it will, because it's powered by AC as well. So you actually run 120 volts right to the birdhouse, wire it in from the back. It's hardwired in. But of course, firefighters, the first thing they do when they come upon a burning building is they shut off the AC. So let's say, here it is, 1 o'clock in the morning, there's no solar, they shut the power off to the building, the firefighter's still going to push this button, and you know what? It's still going to shut off the PV array, because we have battery backup inside of there. Not only is it going to shut off the array, it has voice, it talks to you, it knows whether it's daytime or nighttime, and it tells you whether it's safe to go up there, in which case, in nighttime it would be totally safe. It also tells you during the daytime that there are still lethal voltages up to the combiner, and it tells you the combiner is a gray box with a red handle on it. So we've put a lot of work into this, trying to come up with every scenario possible to make sure it's going to work. One more thing that this isn't showing is you can daisy chain. So you can turn off a whole bunch of combiners, and frankly, I'm not sure we have found the limit to how many combiners will shut off. You can also have additional birdhouses. You can have 3 or 4 or 5 birdhouses. Let's say you've got a Costco store, and you might want one of these in various different places on the Costco store. So you can daisy chain them. There's 2 jacks on the inside of here. Well, something that just came across my desk here a few days ago is a proposed change to the 2014 code that's now going to require this style of shutoff. They pulled the requirement that would make a module level shutdown required, like a Tyco, and they are requiring, I'd swear it was written by Midnite Solar, because it's basically our disconnected combiners, our birdhouse, and in addition to that, it's also requiring the shutdown of a battery-based inverter. Well, no one can do that. Remotely shutting off a battery-based inverter? Well, we can do it. We actually have in-house right now 250 amp breakers with shunt trip capability. And so those can be put into our e-panels. It does take a little circuit board that does the actual turning off. And we can shut off as many battery-based inverters as need be as well. At the same time, we're shutting off the PV combiners upstairs. So this is pretty cool, and we already have the products available. We're building them. The shut-off for the battery-based inverters is something that's coming, and that's only a couple of months away. And by the way, you can thank SMA for that. We're building an e-panel for SMA, very custom, and they are the ones that actually requested to be able to shut off the battery breaker from the birdhouse here. And then a month later, lo and behold, here comes NEC requirement. So we kind of like that. It was just ready-made for Midnite Solar stuff. Oh, speaking of SMA, AC coupled systems. We're going to be getting into AC coupled systems very large. This is one of them. As you can see, there's a Sunny Island inverter in the middle here, big yellow box we're all familiar with. Below that is a Midnite E-panel. Above that is the Midnite auto transformer. We did not use the SMA auto transformer because it's $2,300 retail and it's physically larger than the inverter is. Couldn't quite fit it on anything that we could build and ship away. So what we are actually using, though, is we're using their toroid, made in Poland, shipped over to us, and we just put it in our own box. The system looks nice enough. It looks like it's all designed to fit together, and of course it is. We decided not to even put our own logo on the fronts, just because it didn't look right. SMA doesn't splatter their logo all over the place either. It's a pretty cool looking system. And we're awaiting our first articles on these yellow covers. They should be showing up in a week or two at the max. And then we're ready to roll. All we need is the production plastic, which comes from China. All the rest of the metalwork and whatnot is on order, and it's already ETL listed. You notice a picture of the battery box here. That's actually not the correct configuration we'd be shipping out with it. But what we're trying to do with the AC coupled system is make it simple and easy and not intimidating for the grid tie installers that aren't familiar with battery-based systems. I've talked to so many different grid tie installers over the years that what they do is they talk their customers out of battery backup, mainly because they're not quite sure how to do it. Because you add that word battery in it, things just get 10 times more complicated. So we're basically going to ship away a system on a pallet that's got the battery box, it's got the whole entire AC coupled system tested, pre-wired. It's a plug-and-play system. I can't tell you what the price is. I frankly don't know. Won't be real cheap. But we will be able to ship these things in just a matter of about 2 months now. SMA is real excited about this. Not only does it, is it geared right for their Sunny Island system, but it's always been hard to install a Sunny Island to meet code. You really got to beat your head against the wall to figure out how to deal with Sunny Island. It really wasn't designed for the American market. Well, the missing part was our e-panel. The inside is very similar to like what we do on XW. I think we have a picture of it coming up. Okay, why AC couple? Well, in case you don't already have this one figured out, the reason you want an AC couple is, let's say you got a Sunny Boy $30,000 system on your house or your customer's house. It's not going to do you any good during a power outage, of course. Customers don't always know that. Of course, you as installers and dealers do. So why not have some limited power during an outage and be able to use that expensive $30,000 system that's up on your roof? During the day, you want to be able to use the Sunny Boy. What it does is it just backfeeds the Sunny Island inverter, charges the batteries, and it runs a sub-panel in your house. So it can either be a square D box that you add into your house, or you can use the extra breaker spaces inside of our E-panel. There's about 230,000 Sunny Boys installed at present in the United States. This does give grid tie installers something to go back to their previous customers and offer them an upgrade, battery backup. If they happen to be back in the East Coast where it was a sandy territory, the hurricane, you might just get a few sales. The Sunny Island and the Sunny Boy are without a doubt the absolute best combination for AC coupling. That doesn't mean you can't do other ones, but they were designed to work together. What happens, I don't know if the next slide covers it or not. Yeah, not very well. What happens with the Sunny Boy here, you know, this is German engineering again. They got a 240 volt inverter. We have to have an auto transformer because the Sunny Island is only a 120 volt inverter. By the way, they will be having a 240 volt Sunny Island, but I've been told it's a long ways away, over a year. That's good because we spend a bloody fortune on that yellow cover. In any case, so we're running through the autoformer from the Sunny Boy down to the output of the Sunny Island. That goes down to our E-panel, which is nothing more than some circuit breakers and terminal bus bars. And when the sun is shining, the power now goes back out to the main distribution panel. It is also going out to power backed up loads. Remember, the Sunny Boy is now hooked up to the output of the Sunny Island inverter. Of course, the Sunny Island inverter is a pure sine wave inverter, so when the grid does go down, the Sunny Island quits charging batteries, it starts inverting. The Sunny Boy thinks that the grid is still there. The connection between the main distribution panel here and our E-panel is broken because the Sunny Island disconnected its contactor inside. So there's no way you're ever going to sell power back to the utility during an outage. That cannot happen. But what's happening now is the Sunny Boy is still going through the autoformer. It's still going through the Sunny Island. It is actually charging the batteries, and the Sunny Island is powering the loads. Now, let's say you've only got 1,000 watts of loads on in your house during an outage and the sun is shining. If you've got a 5,000 watt Sunny Boy system and you're producing 5,000 watts, what would happen is typically you would overcharge your batteries. But because the Sunny Boy and the Sunny Island do communicate with each other, the Sunny Island tells the Sunny Boy to back off. It's already got enough power. Don't overcharge the batteries. And so it's a very controlled charging. At the same time, the Sunny Boy goes into off-grid mode, and instead of disconnecting at 59.5 or 16.5 hertz, it greatly opens up that window so it will not disconnect. Because now it's basically your charge controller is what it is. And it's just going to keep on pumping power into the batteries as long as the batteries need it. The problem with everybody else's system, when it's not the Sunny Island Sunny Boy combination, is it's an uncontrolled battery charging. Because you're coming in from the back end of the battery-based inverter, and that's not where all the control circuit is that governs battery charging. So it's easy to deal with. You have to put a contactor in series with the grid tie inverter. It doesn't have to be a Sunny Boy. It can be a Fronius, Aurora, anything. But since it's an uncontrolled charging, again, if you've only got 1,000 watts going on in the house and you got a 4,000 or 5,000 watt grid tie inverter, you're very quickly going to overcharge the batteries. So now you have to disconnect it, and it's based on battery voltage. If you have, let's say, an outback inverter, it's got the auxiliary outputs. That can be used, and they're programmed by battery voltage. So that can be programmed to shut off a relay. And we use solid-state relays for reliability reasons. What it does is it disconnects the grid tie inverter until such a time as the battery bank drops down to a safe level. Then it connects up to the grid tie inverter again. not a big deal because your batteries were fully charged. So, you know, you say, well, I want to use my power from the solar array. Well, you can't because the batteries are charged. Go buy a bigger television, I guess. The Magnum, they have a relay built into their new router, so that takes care of it. And that relay would also power a solid-state relay, and that's what we use on the Magnum system. If it happens to be an XW, and we don't build an XW AC coupled system, but we certainly do the E-panel, I have been told, and this requires some checking, I've been told that the XW will frequency shift to the point where it'll knock the grid tie inverter offline. It doesn't do a coordinated charge like what happens with the Sunny Boy and Sunny Island, but you don't have to add an external relay, which is kind of nice. But we were also made known just yesterday by somebody talking to Schneider that if you AC couple a Sunny XW inverter, you voided your warranty. So there is some checking required. There seems to be some discrepancies here. We've also heard different things from Enphase. It's very, very difficult to get inverter manufacturers to say yes or no about AC coupling. And I'm not talking about battery-based. Yes.
That was not true on Snyder. I did talk to them directly, and they fully support and endorse AC coupled.
Good. That makes life lots easier. So you do not need the external relay when using the XW inverter. But you do have to have it with a Magnum. You do have to have it with an Outback. So there's many different ways to do AC coupling. We've got a whole 4-hour presentation on different ways to do AC coupling, and maybe we'll have to do that. Maybe condense it down to a couple of hours. But basically what we're trying to tell you here is that we do all sorts of different AC coupled systems. They're pre-wired. They come to you tested. Let's see. Oh, this is the direction we're supposed to go. We make it easy. And it is intimidating. It's even intimidating to a lot of the old-timer off-grid installer guys that understand batteries. But if you've never installed systems with batteries, it's really complicated. Here we're just talking about the E-panel. Big deal. Yeah, it's finally coming, and it's a really nice E-panel. By the way, it can also accommodate a second input. I think we'll have a picture here. Good. This is an SMA Sunny Island E-panel. This one happens to be wired. You can see breakers here and over here for charge controllers. Those would not be there when it's an AC coupled system. But this circuit board here that has 2 relays on it, this is what gives you a generator input or the utility input. Just yesterday we decided that we really need to add a 3rd relay here so that we will never ever backfeed a generator. Generators typically don't work well enough to keep a grid tie inverter online anyway, but it is possible. And what would happen if you had a 6,000 or 8,000 watt PV array and a 3,000 watt, let's say the Honda inverter generator, which is good enough to keep a grid tie inverter up and running? You would fry the generator. It would backfeed the generator, and it's okay to backfeed the utility. They like it. You cannot backfeed a generator. They will die. So by adding a 3rd relay, we think we figured out how to make this goof-proof. This will be not only an option inside of the SMA E-panel, it will also be available as a standalone box. By the way, you can thank David Katz in the industry for coming up with this issue of backfeeding generators. It's something that we had not thought of. He pointed it out to us, and thanks to him, we're going to build a bunch of these, and it'll probably be the only thing on the market to goof-proof a second input. A little more on the SMA inverter system. SMA themselves support more than 4 Sunny Islands on the big systems, but they ask us to take care of 1 to 4 Sunny Islands. So this is the biggest system we will do, but what you're looking at here is you're looking at 4 250 amp breakers coming from a single battery bank. 1,000 amps potentially. That gets to be kind of hard to deal with. So we came up with what we call our battery combiner. It's got a 1,000 amp shunt in it. It's got all the connections you need for hooking up multiple 4-aught or 250 or 350 MCM cables going down the battery bank. And all the conduits and whatnot are in the right place, all the knockouts, so you can feed up to 4 sunny islands. As it so happens, you can put 2 radians right in the same place as those 2 center sunny islands. And now we can feed, again, it's 1,000 amps because the radian has 2 breakers in it, but up to 1,000 amps on 2 radians. And by the way, we can do a slider for the AC bypass that happens to be over on the left-hand unit in all cases. The AC bypass switches all 4 of these inverters at once. It can also switch 2 radians, and it's built into the E-panels, of course. But it's interesting to note that Outback can't even select 2 AC input-output bypasses on their radians. They can only do the single one. So, SMA AC coupled from 1 to 4 systems, 4,500 watts to 24,000 watts. That pretty well covers what you'd want to do on a residential system. If you need to go bigger than that, then you need to go directly to SMA. They can handle bigger than this. The nice thing about our systems, they're all pre-wired and tested, and we just ship them out. In-phase AC coupled systems. There's a lot of in-phase installers out there. And believe me, they should not be allowed to mess with batteries as a general rule because they've never messed with them. A lot of them were plumbers before they were in-phase installers. Well, what we do for in-phase installers, and of course it could be a Fronius, it could be a Sunny Boy, it could be anything, but in particular in-phase, is we offer this, what we call the Magnum PAE system, where inside of our battery box, let's see if we have a picture of this. Now we got a schematic. Inside of our battery box, we put the 240-volt Magnum Energy inverter. We do add the solid-state relay, which is controlled by the router that Magnum makes. And basically, we're making the whole system, again, plug and play for the installer. So here, let's go over things. Your solar array, okay, yeah, you got a disco combiner. We're just shamelessly advertising that here. You may or may not have a combiner. It might go straight into a grid tie inverter. And this can be anybody's grid tie inverter. That goes right to the output of the Magnum Energy inverter. It's already 240 volts, so it matches up with most grid tie inverters. Typically, it's going to go right back out the input of the Magnum out to the grid when the sun is shining and the grid is up. We're also, at the same time, when the grid is up, the Magnum Energy is controlling the charge on the battery. And that's the same with the Outback, everybody else. The uncontrolled charging only happens when the grid is down. So make sure you get that one straight because it's really important. The relay is not being used when the grid is up. But there is this relay which is actually inside of our system. We're not showing it in the battery box here. But the Magnum Energy will power a critical loads panel or a sub-panel when the power is out. The utility is powering this critical loads panel when the utility is up. So you have a limited amount of power based on how big the battery box is for when the grid is down. Yes, you can have a second input to the Magnum as well by using that little circuit board we just showed you. Fire up your generator and it'll take over, power your loads, and charge the batteries. And it will be controlled because of that solid-state relay. We can't overcharge things. Oh, by the way, no, that was not true. You will never, ever have the grid tie inverter physically or electrically connected to the Magnum inverter at the same time the generator is connected. And this is what those 3 relays disconnect. The other solid-state relay takes care of disconnecting the grid tie inverter when the batteries get too high. This is why it gets a little complicated. Sometimes it's a little much for me to grasp. I especially feel bad for the in-phase installers. We just did a big training in Hawaii a few weeks ago, where most of the people in the class were in-phase installers. And believe me, they're going to be buying a whole lot of these systems because we're making it pretty much plug and play. Here's the system that they're going to buy. This is what we just described. Here's the Magnum router up here. This has the little relay that turns on and off the solid-state relay, which is back behind here. You need all of these breakers. Here's an AC transfer switch, or AC bypass, excuse me. You always want an AC bypass switch when you have a battery-based inverter, always. So if that inverter breaks, your lights are out. And you're going to be back behind here trying to rewire stuff to get the lights back on. So it's much easier just to throw the bypass switch. Go fix your inverter. Comes with cabling for 24 volts worth of batteries. Right now these are the Concord 3050Ts. I just wired up I think they're 4050Ts in this same basic box at my house. They're 3 inches taller, so they don't exactly meet the 6-inch rule by the NEC code. Wasn't a big deal to do, and you get a lot more power by using the 4050Ts, but remember you only have 3 inches of clearance. Anyway, this is the standard product that we sell. We don't ship it with the batteries. That's up to the distributor to supply the batteries as well. And we do drop ship these right to the customer's house, whatever the dealer or distributor requests. This is just showing the shelf, the same exact thing. You do get a GFCI outlet, and here's the breaker that powers that. Here's your AC bypass. Here's your AC input breakers. These breakers here, I think that has to do with the grid tie inverter coming in. That's a disconnect. And then, of course, over here is your 215-amp breaker, which someday will be able to be shut off by our birdhouse. Boy, these things are getting complicated. And here's just the bottom shelf with batteries in it. Here's the battery box, big deal. Here's the same battery box now. All that stuff you saw is inside of this. It actually looks pretty nice. This is a house in California, I believe. Doesn't look too bad. Radian AC coupled system. We are actually starting to build some Radian Radian e-panels here next week. The first real ones, the second and third ones we built. We did our AC box, AC and DC box, a little different than what Outback did. They basically copied a system that I dropped off at their engineering department that we designed 3 years ago for the Radian. But they don't like CBI breakers, and to me they made a mistake. When you look at the Radian circuit breaker box, I can't remember what they call it, they use the Carling panel mount breakers. They're good breakers. I like the breakers. We use tons of them. But you can't get at them. You can't get your hands back there. You're trying to wire them up blind, and there's no way to see what you're doing. We do offer those breakers on the Radians and XWs and SMAs as well. And we also offer the din rail mount CBI breakers, so you got your choice. One of the big differences, though, is we mount our breakers on the side, so you have good access to hook them up. You can actually see what you're doing. Another feature that we have on our e-panel versus the Outback is we can accommodate 2 Radians. What we do is we actually have a different slider that's longer, and instead of having the normal AC bypass and 2 different input breakers on one e-panel, we take the AC input breakers, move them to another side or another panel, and now we've got all those breaker spaces available for an AC bypass for 2 Radians. This is something that Outback could have done, but they just didn't think it through well enough, I guess. Okay, so here's an e-panel. Yeah, we offer the e-panels either for power backup, for off-grid with charge controllers here. They can be AC coupled, add your own battery box, basically have it your way. So it's pretty easy to customize stuff because it all uses the same parts that we always have around. They all come with lightning arresters up here. And, well, they all come with, when they need a charge controller, it's always the classic. We no longer offer any other charge controllers because we have our own. Okay, so much for that. You need a big Magnum system? Here's a 16,000 watt system using our Nada gutter. There's some additional breakers over here. I'm not sure what those are being used for on here. They could be AC input breakers. The AC input breakers can also be on each individual E-panel. And these are what we call ultralight E-panels. They're stripped down. There isn't much inside of them other than the big battery breaker. XW series. Schneider actually really likes our XW E-panel because when it's a single E-panel or a single inverter system, they're not very competitive using their own distribution box because they have a $1,500 box that's made for up to 3 inverters. Our E-panel is made for a single XW, and you'll save $550 over the price of their distribution box. You also save 10 square feet on your wall, which is sometimes hard to come up with. Here's the non-AC coupled version of the Sunny Island system. So it's just an E-panel with the Sunny Island. We do offer all of the components and back panels and E-panels and stuff separately, or you can wire them or order them pre-wired. Again, we don't know the price of these yet. We hope to have the prices up here within 2 weeks. We're still waiting for all the prices of all of our custom sheet metal in the plastic. And this is the same E-panel we saw before. Here's a picture of the E-panel for the Radiant, except you can't see it because the yellow door is in the way. Oh well. And that's some people from SEI there and Ryan. Outback E-panels, most people know we do make Outback E-panels. There's skinny ones, there's wide ones, there's steel ones, there's aluminum ones, there's the plus ones. They make all sorts of E-panels. And again, they're much, much cheaper than what Outback offers. We do about the same price as what you would call a FlexWare 250, although I would never recommend that to my friends just because it's too hard to wire. It's too small. Here's a dual Outback system on our back plate. We do a fair amount of these. The main difference between this and a pre-wired Outback FlexWare 500 system is you see the physical separation between the inverters here. You got about a foot or two between the two. Well, what happens here is you get really good cooling between the two inverters. On the Outback system, you've got 1 inch between the two inverters, and the top inverter and the bottom inverter, they get too hot, and it causes problems. It makes you run your generator longer because the chargers back off. When it's a quad system, the third inverter up is the one that always breaks. It's not a reliable system. Here's a quad stack. We've done as many as 8 stacks on 2 of these Navigutter systems. You can actually switch 8 Outback inverters though with 1 switch of the handle. Outback can only do 4. Not a big deal because there aren't that many really big systems. Mini DC, there aren't a whole lot of boxes left since Xantrex quit building the DC250. We do a lot of these boxes. They're very simple, very inexpensive box with 125, 175, or 215 amp breaker. We got DIN rails here. We give away 2 side plates. You can either put 3 of the Carling panel mount breakers here or up to 5 of the DIN rail mount CBI breakers. You can add a bus bar. There's the mounting holes for a bus bar on all of these. We just make a right hand, a left hand, and a plus. The plus just has additional bus bars. Okay, now we're getting into our lightning protection. This is just our most recent ad in Solar Pro magazine. Like I said, the reason we designed our SPD is because we found out the deltas just don't work. I typically tell people, go buy yourself a donut. It'll do you more good than hooking up a delta. Delta is 3 wires stuck in sand. So we right now at present have 3 models, 115 volt, 300 volt, or 600 volt. Those are all DC ratings. The 115 can be an AC rating. We don't recommend putting the 115 on a 120 volt AC circuit. It's really designed for battery voltage type stuff, up to 115 volts. But don't put it on a 120 volt circuit. That's getting too close to the threshold where it starts interacting. The 300 volt SPD is good for 120 and 240 volt AC, or up to 300 volts DC, like for a charge controller. And then the SPD 600 that we give away with all of our new combiners is it's mainly made for grid tie. Yeah, you can use it for three-phase high voltage stuff in AC too, but it's mainly made for the 600 volt DC stuff. Okay, what else? Oh, these are all NEMA 4X rated. You put them out in the rain, out in the snow, cold. You have two blue lights. See this blue light here and that blue light there? Those are on when there is voltage present. So that means that you've got AC present 24 hours a day and they're lit up and you know it's working. Or when the sun is shining on a 600 volt unit. You want those blue lights on when you know that there's voltage present. If they are ever off, that means that the lightning arrestor is actually broken and it needs to be repaired. All of our lightning arrestors are repairable. So that is something that no other lightning arrestors can claim. I guess plug-in Cytels, yeah, you can do that with. And you will need to do that with those because they only have a single MOV for plus and minus, and they're going to break because they're not very strong. We actually put 8 of the 18,000 amp MOVs in this SPD because we just don't want the things to ever break. But we did make it repairable. The cap unscrews. It has to be done here at the factory because it doesn't unscrew very easily, which is intentional so it doesn't leak water. Here's the same. There's a different brand of MOVs inside. That's why it's a different color. But the same thing here. This is what you actually get. The SPD 300 is easily used on AC systems right at your distribution panel. Now, a lot of distribution panels are flush mounted on sheetrock. Not so much on the East Coast where they're surface mounted. And if they're surface mounted, you just find a knockout in your distribution panel and run our SPD directly in. But if your distribution panel is in sheetrock and is flush mounted, well, there's no real good place to attach our lightning arrestor. So we make this what we call the cut-in box, and it comes with the conduit and the fittings and bushings and all that you see, and it just mounts directly next to your distribution box. I have one of these in my house, and it's funny because every time I walk down the hall, the doors open where this distribution box is, I find myself looking at the lightning arrestor just to make sure both blue lights are on, because it gives me the the satisfaction of knowing that the house is protected. Pretty cheap insurance. I have had things break at my house from lightning. Here's 6 of these on a fairly large grid tie system in Montana. You see they just stuck them on the top of it so they're easy to see. If all the blue lights are on, they're all working. By the way, out of the thousands and thousands and thousands of SPDs we've shipped, we've had exactly 1 failure. We've had a couple lights that didn't work. They probably never worked when we shipped them. We didn't test them properly, but only a couple of those. But we actually had 1 blow up, and that was a direct lightning strike. We can only accept up to 115,000 amp surge. If it's going to be a 500,000 amp surge from a direct lightning strike, okay, it's going south. Nothing can protect against that, at least not at this level. There are some multi-$1,000 surge arrestors that they use in telecom that could certainly take care of that. These are fairly inexpensive units. They retail for $119. By the way, if any of you are familiar with the DIN mount Cytels, which are nice devices, they're MOV-based like ours. But I see 2 issues with them, well 3 issues with them really. They only give you 1 MOV per section where we give you 4. They are DIN rail mount, so they're typically inside of a combiner box, and when they do break, you will not know that they're broken until the next lightning strike, or lightning storm, when your inverter breaks. But also, the weak ones, the ones that only have a total of 2 MOVs, they wholesale for like $160, is what I've been told. Our whole thing, which is 4 times stronger, retails for $119, so it's quite a price difference too. probably why we sell a lot of these little buggers. Battery capacity meter. We touched on this earlier. This is what it looks like. These were really designed for Lincoln Doll at African Energy. They just buy tons of them going over to Africa, where they have one solar panel, one battery. They got a few lights in the house or hut or whatever it is in the village. And the whole goal here is to keep that battery living longer. And so we have a state of charge, which is nice, and they learn over time, well, if you're down to 50%, maybe they shouldn't be turning on the lights for X amount of time. But the best thing about this battery meter is the three lights that are over on the left-hand side, the green, the yellow, the red. You can see the label down below, smiling face and frowning face. It tells you how long it has been since your battery received a full charge. There's a little jumper inside that selects between lead acid, AGM, and gel. So we have different voltages that are the trip point. When it gets up to the trip point, it has to hold the charge for, I think, well, it used to be 2 hours. We might have reduced it a bit to an hour and a half. And what happens is if you reach that predetermined voltage level and it's held up for an hour and a half, it turns on the green light. So you're good to go. That means you run your loads. Your battery's got a full charge. You're not going to sulfate them. They're not being undercharged typically. I have one of these on our forklift here at Midnite. The red light never goes off. So I did a little research and I found out that our forklift charger was only getting the batteries up to about 57 volts. It just wasn't a good charger. So we threw that out and I bought an Outback 48-volt inverter, and we just used the charger section on it, which is fully adjustable, and now I can get the voltage up. But even factory-made stuff like a big forklift charger that weighs 500 pounds doesn't guarantee that you're getting your batteries fully charged. Controllers. This is Bob, my brother. He designed this guy here, MX60. Of course, he did ours. Here's the XW, and here's the Apollo. I don't really know much about the Apollo, except that they're nice people. We know quite a bit about the Xantrex. One thing that's interesting is, it took Bob 1 year working all by himself to design the Outback MX60. Bob and a whole host of other engineers have been working on the Classic for over 7 years. We've been producing it for 2 years now, and frankly, it probably still has another year to go. We still have more features to put into it. All the software in the Classic is upgradable. Eventually it'll be upgradable right over the internet, but right now you just download files from our website and use a laptop computer or whatever into the USB port, and you can upgrade the firmware. There's no cost associated with this, and all of them are upgradable. Like I said, there's still a few more features that we're adding to this over the next 6 to 9 months or so. Here we have a light version. This is a light. We had a complaint from one of our big dealers that they knew the Classic was the best controller in the world, but they had trouble selling it because the perception was it was expensive. Well, of course, we were comparing it to like an 80 amp Outback, and they were the same price. Well, what they were talking about was people were buying either the 60 amp Outback or the 60 amp Morningstar or the 60 amp Xantrex. And we're an 80 or 90 amp controller. So we came up with the light where we stripped out the display. And by the way, our display, our graphics display, is easily 4 times more complicated than the entire Outback charge controller. It's just that complicated. Easy to use, but there's a whole lot of stuff going on inside. And we've also taken out the arc fault detector on the light. Even though arc fault detectors are required by the NEC code, and they have been since 2011, no one else in the industry has an arc fault detector, and of course there is an expense associated with putting that into the controller. So now we have basically a stripped down version. You still get all the same power, you still get the Ethernet, you still get 380 days of data logging, You still get a wind controller, auto equalize. You get all sorts of things. You just don't get the graphics display, and you don't get the arc fault detector. You can always go back and add the graphics display. But what you have here with the Classic Lite is basically a 90 amp controller that's the same price as everybody else's 60 amp controller, and we give you way more features. So this is the Lite. Terrible picture of it, but that's what it is. Here's something interesting. This was done over at Ryan's house some time ago, quite a while ago now. It was actually done by APRS World. We did not do any of the monitoring. This data was taken off of the APRS World website, and they built the custom monitoring equipment. What we did is we just picked an average week, and it could have been any week. They're all pretty much the same, where Ryan has 3 identical arrays. They were calibrated to be identical by the APRS World current sensors. So we know that the 1,000 watt array on array 1 is the same as the array 2 and the same as the array 3. There is no difference. I never thought that there was going to be much of a difference on MPPT controllers because, you know, they have to be like 97 to 99% efficient. But turns out there is a big difference, and it's not all the powertrain, which is the power electronics. A lot of the difference on how these things act is the actual software and how well they track the sun. We actually have 4 different algorithms that will switch in and out on the Classic based on the sun and what things are doing. It just makes up its own mind on switching between algorithm 1 or 2 or 3 or 4. The other guys have 1 algorithm, and so that's part of what's going on. We also have extremely good power electronics, the heat sinking, all of the FETs and the inductors, and the power stage. We do a better job of that than some of the other guys. But here you'll notice, if you're looking at this, let's take day 1, 2,163 watt hours, where the Outback put out a couple thousand, and Xantrex beat them by a little bit, basically 21. It's, yeah, I think the worst case is like 7–8% difference here. Day 2, we had a much sunnier day, and we're at 3,800 watt hours, where the Outback's way down to 3,500, and the XW was even less. I'm guessing it's less because things get hot on the XW. They really only have 4 transistors in the XW, and they don't use synchronous rectification, so that gives them another penalty on power production. And we do a good job of heat sinking. We have 8 transistors. Outback has 12 transistors. But we do, I think we have better transistors, and we do a better job of heat sinking. So power electronics is about equal here. These guys are at a disadvantage because they just cheapened it up too much. But our algorithms on how we charge are just far superior. Every single day of the week here, we outperformed Outback and Xantrex. And these guys would flip-flop back and forth on who was the best on each day. One thing that's not on this chart is the Morningstar. We didn't have a Morningstar at the time we did this, but I wanted to mention that if we had put the Morningstar up here, it would have been virtually identical to the Midnite. The Morningstar is a very good controller. Now, what you get for the same price as a Classic Lite is you get a 60 amp unit, and if you try to hook up the internet to it, good luck. We gave up. But it just doesn't have the features of the Classic. But to be fair to Morningstar, it would have been putting out virtually the identical amount of power as we did. It's a very good controller. It is made in China, however, and we're not. Hyperblock. This is just one of the features that we have. Not everybody understands Hyperblock. If you're on the East Coast or up in Canada, it's pretty important. In the colder climates, if you're in Arizona, it probably doesn't much matter. What happens when you've got, let's say, a Morningstar or an Outback 150 volt controller, and you put enough panels in series where on a cold morning it reaches 160 volts? Well, a couple things can happen. Number one, you have just voided your warranty. Number two, that controller did record the highest voltage just before it blew up. and you will not have a warranty. When it comes to the Classic, Bobby knows a lot about controllers, obviously. He put a circuit in here called the HyperVoc, and once it reaches that magic 150 volt operating voltage, it shuts off, and now you get to add the battery voltage to that operating voltage, and this is a non-operating HyperVoc zone, or a safe area. So in the case of this purple line here going above the max input voltage, this is a 24 volt battery evidently, and you can go up to 175 volts open circuit. It will not hurt it. It is not operating, but it won't hurt the Classic. If this was a 48 volt battery bank, you can go all the way up to 200 volts open circuit. Try that with an Outback or a Morningstar or an Apollo or an XW. I know what's going to happen, but I also know what will happen on ours. Nothing happens. Classic versus the Classic Lite. Not everybody really understands the differences, but basically they're the same unit. You just don't get the graphics panel here. Notice there's no keypad over here. There's one button, and that's to start an EQ. You do have error lights. I can't remember what the other light is. Ground fault or arc fault lights. And there might be a clipping light. I can't remember. And then you have a light that goes on when you're EQing. Over here, of course, you get the whole keyboard, all the programming. You still get all the programming on a Classic Lite, but you have to hook up a computer. And that can either be direct or that can be over the internet. And then you get to use what's called our local app, and it's two-way communications. You can do all the programming. Or you flip off the cover here and there's dip switches underneath. And that's how you program the battery charger settings. We tried to copy as much as possible the exact same dip switch settings as what Morningstar has. Why confuse the general public out there? They did a good job of setting their dip switches. I personally do not like dip switches because they're confusing to me. But this is one way to reduce cost, which is what that one dealer wanted. By the way, that one dealer that complained about our Classic being high cost, they are now our absolute biggest account, even bigger than our distributors. Arc fault, yeah, we don't put the arc fault in the Classic Lite. It certainly is in the Classic. It is the only arc fault detector in the entire world on a charge controller. And we've been shipping that for 2 years now. So it's the only controller that's legal that meets the NEC 2011. Keep that in mind when you're thinking about inspectors. Okay, yeah, we don't have the graphics panel, but you can always add a graphics panel. Another way to do this is, let's say you want to stack two controllers. We can now stack network stacking 2 or 3 or 4 or 10 controllers, doesn't matter. You really only need one control panel, the graphics panel. All the rest of them can be lights, because you can actually read what's going on all of the other controllers on the one that has the graphics panel. Because you just go through the addresses and you can look down the line which units are doing what. It's pretty cool. Network paralleling, I just mentioned. We can finally do paralleling. Not everybody can do this. Outback can parallel by using their hub and the mate. Those are added expenses, of course. Morningstar does not parallel at all. I've been told the XW can do up to 3 or 4 with different mixed. Well, have you ever done it? Some people say that they have problems networking XWs, and I think it has to do with when there's too many things on the network. We have systems that have as many as 30 Classics on them now, and we do not think there's any problem networking them. In fact, I'm sure those 30 units will be networked in the future. And there is no hub required. There's no mate required. All you need to do is use telephone wire to connect one Classic up to the next. It's called Follow Me. That is our network paralleling. And how it works is the first Classic, let's say you've got 3 Classics here. If the middle one decides it's time to go to absorb mode, all of them go to absorb mode. And now it's time to go to a float. Let's say the one over here on the right is the first one, due to tolerances. There's tolerances to all voltage measurement systems and timing. But let's say the one on the right is the first one that says, hey, it's time to go to float. Well, it basically sends the signal to the other two to go to float as well. Works quite well. Same thing for EQ. Picking the proper classic, it's not simple. We have a total of 6 different classics now. Do you want 150 volt, 200, or 250? What's your battery voltage? Down in Australia, they have 120 volt battery banks, and they're the only controller there is that will do 120 volt battery bank with MPPT, and 250 volts in. I would suggest going to our string sizer on our website. It really helps you pick the right classic. It's a very nice string sizer that Ryan and Rob developed. In fact, here it is. This is what it looks like. Right now, you have to fill out all this information from your solar panels. Eventually, we hope to have different panel model numbers. You just select that, and it fills it in for you. But down here, you're designing your array. You tell it your temperatures. You tell it how many modules in series and how many parallel strings. You hit the submit button, and boom, you get all sorts of data over here. I won't go over it all, but you'll see on the max VOC, on the classic 150, and it can be a 150 light, it doesn't matter. It says it's marginal. We're going to enter the hyper VOC zone. Okay, well, at what temperature? At 69 degrees Fahrenheit. So that's basically room temperature. This thing is going to go over voltage, and it will shut off. It won't hurt it, but you're never going to get your batteries charged if it goes into hypervoc zone at 69 degrees Fahrenheit. So that would be a misapplication of this particular controller with that particular array. Now you can go up to a classic 200, and it says it's okay. You're not going to go over voltage. In fact, it wouldn't go into over voltage until minus 108 degrees Fahrenheit. Not a problem. It says the anticipated power is okay on the classic 200. But now you go over to the classic 250, you're okay as far as VLC, but it's too much power for it. You would need 1.2 of the classic 250s to basically power this entire 3,760 watt array. Now what we say down here in the fine notes here is, 1.2, it's not so bad. You might be leaving a little bit on the table, but if you want to go for it rather than buying a different controller or 2 controllers, it's not so bad. If you need more than 1.2 controllers, do something different. It's a misapplication. So this really helps you select the correct controller. What it does not take into consideration is the length of wire run, and we hope to add that someday. Obviously, the higher voltage controllers are designed for longer runs. And basically, I usually tell people that if you're 100 feet or less away from the battery bank, from the array, go with the classic 150 or the 150 Lite, because it's the most efficient, as long as it meets all the parameters of your string sizer here. If you're going to be up to, let's say close to 200 feet, the classic 200 is fine. And beyond 200 feet, you want to use the classic 250 or the new Schneider 600 volt unit or the upcoming Morningstar. So you've got choices nowadays. You didn't used to have choices. Does anybody do wind out there? We're the only guys doing MPPT for wind. I'm not going to waste a lot of time on it because most people don't do wind. This thing is a clipper. It's a voltage limiter. You need a voltage limiter when doing wind turbines because what happens when the batteries get fully charged? Well, we basically cut the turbine loose. We quit putting power in the batteries, and it's now going to freewheel. And 2 things happen when that wind turbine freewheels. It's going to spin very fast, and either the blades fly off or it puts out such a high voltage it will break the classic, because the classic is still connected to it. It doesn't disconnect it. The input filter capacitors and the FETs are still connected. And these turbines can sometimes put out 300-400 volts open circuit when they're freewheeling. So that's what the clipper does, is it makes sure that turbine is always loaded, keeps the voltage to a safe level. In addition to that, it allows you to do 3-stage battery charging, because the clipper communicates with the classic, and the classic just says, hey, let's bring the voltage down to 50 volts, because I'm going to charge my 24-volt battery. We're going to float them. It might bring it down to 40 volts. So it's really kind of cool. It saves wear and tear on the turbine, because now it's spinning very slowly. You're trickle charging your batteries, floating them. Life is good. It'll also shut things down during storms based on those same parameters. Videos. This is a couple of guys that work for us, Hank on the right and John on the left. John, by the way, wires our pre-wired systems. Hank tests our BCMs and all the graphics panels. But this is just part of a video that we did. We have a lot of videos on our website now, and more coming all the time. Some of them are quite humorous. Some are just very short and very instructional. We're trying to cover some of the points, mainly on the classic now, where Ryan has done a whole bunch of 2- and 3-minute videos. Let's say you just want to know how to put the classic into EQ mode. Go to our document section here and go to the Power Time videos and go down the line, and it's going to show you exactly how to EQ your batteries or go through the menu structure, how to set the battery charger settings. There's all sorts of different quickie little videos here where you can learn very quickly about the classic. We have videos on our SPDs, on our E-panels, and more coming all the time. Here's what we call our local app. Remember I mentioned how you can make the classic put out on the internet or just hooked up direct to your PC. This is what you see. In addition to that, we have drop-down menus where you get lots more data. This is where you can do a lot of settings. We do a lot of graphing as well. But all these meters here are in real time. This is telling you the name of the classic. You could have 2 or 3 different classics on the network, and you get to name them anything you want. And so we're looking at a wind turbine here that has virtually no wind because it's only 204 watts. Here's your input volts, 73 volts. Battery was 49.6, and there was 4 amps going in the batteries. We do data logging when it's connected. We can now retrieve the data logging, I believe, out of the classic, and there's up to 380 days of data logging stored inside of the classic, and you can read it from halfway around the world now. This is one of the graphs that you can display on our local app, and you get to pick what you want to display. There's 11 different parameters. You can see we're looking at battery voltage, input voltage, and kilowatt hours. But there's 11 different things you can pick. You can put them all on the screen at the same time, although you may not be able to read it because it'll get kind of cluttered. You can pick, by the way, you can pick different types of graphs. They can be bar graphs, they can be line graphs, they can be sketches, kind of weird stuff. Power graphs. I was talking about, the classics at 80 amps, 90 amp. We advertise 96 amps. The reason we don't just say it's an 80 amp controller, because it's really not. Depending on what your array voltage is here, and we have 5 of them listed, and depending on what your battery voltage is, the classic gives you additional boost power. So absolute worst case, 48 volt battery at the absolute highest MPPT voltage, and this is very, very high, 120 volts. It's good for 76 amps is all. And that same PV array on a 24 volt system is good for 82 amps. But if it's on a 12 volt system, you get 92 amps. So you go all the way up to 96 on a low voltage array and a low voltage battery. Things just run more efficient at the lower voltages. What everybody else does is they would have cut off their unit at the absolute worst case down here. So take, for instance, an Outback 80 amp controller. They can be doing all this stuff. They have the power to do it. They have the fans to cool it down. Their software does not allow it. And where it really comes in handy, let's say up here, if you've got a 12 volt system on an RV, you get to add one entire whole additional solar panel because we allow that extra power. We had to actually argue and fight with ETL to allow them to do it this way. Because when you read the UL standards, you've got to label what your output power is, plus or minus 10%. And we didn't want to do that. We didn't want to strap you down because we knew the Classic was good for more power under certain conditions. Well, we won, and you really have to go to our power graphs in order to figure out how much power it's good for under your conditions. And all the different Classics have different graphs. I'm just showing you one here. So that's why I don't really say the Classic 150 is a 80 amp controller. It could be a 96 amp controller. That's why we call it the 150 based on the voltage instead of FM80 based on current. Comparison. And this is just a comparison chart that we run ads for. It's up on our website. We compare us against Outback, Blue Sky, Xantrex, Morningstar, Apollo, and we let the chips fall where they may. There's a few of these features here on some of our competitors that they do a better job on things than we do. Blue Sky, they have an external shunt input. We don't have that yet. It's coming, but we don't have it yet. The Xantrex, Modbus communication, we have Modbus too. Morningstar has Modbus. There was something else up here that somebody else did better than us. I can't remember what it was. But I got a compliment from Brad at Morningstar saying that he appreciated the fact that we let the chips fall where they may. Yeah, we do better. We're listing the things here that we do better on in the most cases, but there are some things where we weren't quite as good. Ain't many of those. By the way, we are just as cheap dollars per amp as anybody, $10.63. This does not include the Classic Light, by the way. We really shine on the Classic Light, which is not on here. Everybody else, except for Apollo, no, here's Outback. They're just as cheap as us, dollars per amp. FM60 is not so cheap. Holy cow, Blue Sky is horrible. Xantrex isn't so bad. Morningstar, it's pretty pricey for what you get. It's a good controller, like I said, but you're limited on power and you're limited on features, and it's not all that cheap. MNDC 15. Because more and more systems are using more and more charge controllers, we came up with the circuit breaker box that will deal with a whole bunch of charge controllers. So that's the MNDC 15. It's just a breaker box. Here's one at Ryan's house installed with 4 Classics. So that's what it would look like. Bunch of breakers, bunch of wires, bunch of charge controllers. Of course, you can use it with anybody's charge controllers. And here's 4 SPDs down here. I highly recommend using SPDs because they're not very expensive. It's cheap insurance. And Lightning is very, very unforgiving. Small breaker boxes, we already covered that. We're the only guys that make a small box for like the Carling panel mount breakers or the CBI DIN rail mount breakers. These 2 boxes here on the bottom are listed boxes by ETL. The little baby box, which we just sell tons of, is not listed. People use them, but it's too small. And the metal isn't thick enough to meet the UL standards, so it's not listed. We still sell hundreds of them every month, sell them all around the world. They're a nice little box. I'd probably use the big baby just because it's listed. 4 DIN rail spaces, no big deal. Same thing here. It's the same box, it's just bigger and thicker to meet the code. You can see the difference. The only reason we did this is because I finally started feeling guilty that the baby box wasn't a listed box, and it could never be listed. But we still build it because people want to buy them, and it's $10 cheaper. Here's the quad box. So that's your, it's a little small for 4 of these Carling type of breakers. I would say if you're going to put 4 100 amp breakers in here, don't do it because you need big wires and it just gets too crowded. Buy something bigger for that, or put 2 of them in here. Mini DC, already talked about. We already talked about breakers. We do a lot of breakers. Not a product, but it's hard to get good technical support. We have good technical support if you can get through on the phones. And we just decided to add another phone line. So we have 3 people that typically answer the phone. None of them actually live here in Arlington, Washington. Kim lives in California, and if you get her, she's a ball of fire. She'll try to sell you something. Or if you get Ryan in Maine or Tom in Hawaii, these are professional installers. They've been installing stuff their whole life. They can answer your questions, not just about our equipment, but about pretty much anybody's equipment. There's Ryan in his office in Maine. Here's Tom just outside of his office in Hawaii. Ryan's journeyman electrician, has been doing this stuff for 20 years. Tom's been installing stuff for over 20 years. They both live off-grid. They're both ham radio operators, by the way, too, if you're into that stuff, as well as my brother Bob. Here, Tom was making fun of people that write into Home Power saying, "Oh, I saw in your picture, blah, blah, blah. He wasn't tied down to the roof. That's unsafe." So he was making fun of that here. He found every safety device he could find and took a picture. Here's Kim. She's in her office in California. She used to work for Hardy Solar in sales. She's very, very technical, but she will try to sell you something. Okay, here's part of our plant in Arlington. We now have 2 buildings. This is just to show you that we actually do manufacture stuff in Arlington, Washington. We don't have our stuff built in China for us. We have parts built for us in China, but none of the assembly is done in China. None of the design is done in China. It's all done right here. And here's Midnite the cat. She lives in our facility. And that's Joanne, who builds most of our standard combiners. That's all I've got for you. Do we have any questions? Surely somebody's going to have questions. Unmute
I'm
yourself.
just unmuting people now.
Okay, are there any questions? Gosh. If anybody's on the East Coast, holy cow, it's 9 o'clock, isn't it?
Yep.
No questions left? I answered all your questions? Damn, I'm good.
I'm doing it right now.
Okay. Well, maybe we're done then. If there's no questions, this was really just an overview on our products. There wasn't a whole lot of in-depth training. I would like to do more of that in the future, but certainly we got a good overview of all the products that Midnite is building. We do have 12 engineers here, by the way. We have a lot of engineers, and we're working on an awful lot of stuff which we did not cover in this. So that'll be coming out later on, some of it a year from now, some of it a year and a half from now. Fun stuff, hard stuff. We have some very good engineers here. No questions? No comments?
Doesn't appear to be, and I just wanted to point out that we are going to be doing webinars on a regular basis, and we're going to set up an email account, training@Midnite Solar. Feel free to email us your suggestions for products you'd like more training on.
Perfect. All right. Well, I guess we'll sign off, and we'll see you next time around. Thank you very much.